Okay, so I'm trying to spare you having to read chapter 3 of Clawson by lecturing on it briefly and answering the questions on the list of potential test questions based on this. Chapter 3 of Clawson focuses on weather and climate. Weather has to do with what is the weather today. Climate has to do with what is the weather like generally in this time and place, usually in that time of year. Two most important factors that determine weather and climate are temperature and precipitation. So how hot or cold it is, and whether there's how much moisture there is in the air, whether it's in the form of rain or snow or somewhere in between. And then at the end, it also talks about, the chapter also specifically focuses on hurricanes. So like I mentioned, temperature and precipitation are the most important factors that determine climate. So temperature plus precipitation equals the climate, or at least what it usually is. Breaking down temperature. Temperature itself is determined by these three factors: altitude, ocean currents, and latitude. And I'll break up each one of those individually. Beginning with altitude, and you already read about this in chapter 2 of Jockish that you read and answered questions for in your homework, where you were introduced to the different altitudinal zones, where beginning and with these altitude zones, you don't have to know the specific number of feet at which one altitude zone begins and another one ends. You don't have to know what can be grown in each of the altitude zones. You just need to know the 4 altitude zones, which one is hotter and which one is colder. So the general order. I might pick, say, 3 of these, 3 of the 4, and then ask, which of these 3 is the hottest, or which of these 3 is the coldest, for example. So you need to know the relative order of them. Part of these altitudinal life zones is that at the top of Tierra Helada is the snow line, the snow cap. And so here we see an example close to Mexico City where there's this volcano that you were introduced to, the Popocatépetl. Even in Mexico, they just refer to it as El Popo, a little bit easier. And you can see the tree line at which, at a higher elevation, the trees don't grow, and then the snow line, kind of the snow cap of this mountain. And it actually turns out that here there are actually 2 volcanoes. One is El Popo, and the other one is Itzachiwa. And they just refer to it as Itza, so they refer to them as El Popo and La Itza. And there's this whole cultural significance of these volcanoes going back to the Mexica, the Aztecs, and this image has to do with that idea. That story about it having to do with a young couple and Aztec couple, and the man goes off to fight in war, and he doesn't come back right away afterwards. The young woman dies from grief, thinking that he had died. And then when he actually is able to return, he finds that she had died. And so then he kneeled next to her until he died as well. And so then El Popo and La Itza are supposed to represent this story of these 2 people and how they were in love, and it's kind of a sad story. All right, so altitude was one of them. Ocean currents is another. These are the cold currents in the Americas or in Latin America. The warm currents and one that can switch depending in which direction it's going. So cold currents always go in the direction from the pole, either the North Pole or the South Pole, and they go in the direction of the equator. And so that's what makes them cold, is that they're coming from a colder part of the planet toward the warmer part of the planet. The warm ones are the ones doing the opposite, coming from the equator and going toward the pole, like this example of the Brazil current. The equatorial countercurrent, well, it's kind of right at the equator, so it can vary. Important thing with regard to temperature, and it'll relate to precipitation as well, is that a cold current makes the land on the coast both cool and dry. The warm currents help make the land that it's next to be both warm and humid. So warm currents bring rain, cold currents help make it dry. And so the currents in the ocean affect what the climate is like inland. We're also introduced to El Niño and La Niña. El Niño, the Southern Oscillation Current. And it can be a little bit complicated. There's this video that helps me explain it visually. Let's see if it's working. And let me make sure that it makes it to the recording. Sorry, that's as loud as it gets. Oh, a little bit more. This is where the ocean begins to interact with the atmosphere. Colder water results in relatively high pressure, and the warm water results in relatively low pressure. Just like anywhere, low pressure and warm moist air, right in the air, but a lot of so much of the rising air going back to South America. Then cools, descends, and starts the circulation all over. Now for the warm phase of Virginia. Weaker easterly trade winds cause less upwelling along the South American coast. While warm water would expand further east toward South and Central America. The area of low pressure expands the warm water, and the area of high pressure shrinks. Thunderstorm activity expands the warm water to the east, which then leads to a shift in equatorial trajectory. The cold phase of Enso, or La Nina, is the complete opposite. Easterly trade winds are much stronger, which combines with warm surface water further west and allows for greater expansion of upwelling off the coast of South America. Centers of relatively high and low pressure are shifting further west as well, along with thunderstorm activity being further west and again, once again leading to a shift in the trajectory. So now that you are thinking, what does all this about trajectory mean? See surface temperatures in the Pacific and weather conditions here in North America. Well, think of the old adage about when butterfly flies to make everywhere around the globe, you may feel the index here. Well, think of Menso as a much larger butterfly flag against wings. When the gesture moves such a large area, like the Pacific shifts, it affects the shape of the home. In some places, the change to weather is negative, shown in red, but in others, the change can be drastic, shown by the highlight areas. For instance, the southeastern U.S. can expect wetter and colder than normal winter in real. Thanks for joining me, and I hope this video helped you understand the annual southern oscillation a little better. So yeah, there's this idea that there's a normal way, kind of the normal way that weather patterns exist on both sides of the Pacific Ocean, and those conditions get pushed either further east, uh, and that can change how the whole system works. So okay, then we have latitude. And in the previous class, I talked about the tropics and what they mean. And so yeah, closer to the poles, it gets colder. Closer to the equator is warmer, but it's actually more complicated than that, because it's actually at the tropics themselves, Tropic of Cancer and Tropic of Capricorn, where it actually gets the hottest, or can get the hottest at a certain point of the year. So it's not just the equator. Um, let's see. So Tropic of Cancer coincides with Mazatlan, Mexico. Here's Jeff DeGrave, former professor of geography, now in charge of the Center for International Education, I believe. And so he's a geographer. When he goes to Mexico, he goes to places of geographical importance, like the Tropic of Cancer and this old sign. Here, a former student of mine sent me a picture of the Tropic of Capricorn. And again, at the tropics, at the Tropic of Cancer, the Tropic of Capricorn, 23 and a half degrees north and 23 and a half degrees south, can get hotter than the equator. So it's not, yeah, it's not that the equator is always the hottest. It can get hotter than the equator at the Tropic of Cancer and Tropic of Capricorn. All right. So the first part was mostly talking about the things that determine temperature. Now we move to three things that determine precipitation: rain, snow, etc. So they are continentality, shifting atmospheric pressure belts, the prevailing winds, and the orographic effects. And so talking about each one of these individually, first beginning with continentality. And actually, Latin America has very little continentality, or very little dryness, aridity that comes from continentality. This can be counterintuitive, because when we see the typical map that we're used to seeing, it looks like South America is very wide, and there could be continental dryness in the center from being so far away from the oceans. But that's actually not the case. If we look at different ways of showing the globe on a 2D, on a two-dimensional flat surface, and there's more than one way to do that. The typical one we are used to seeing is a Mercator projection, but there is all these different ways of trying to demonstrate more accurately, actually, what the land masses actually look like. And long story short, they all, or most of them, demonstrate South America as being much more, what would be the word? Kind of like long, I want to say vertical, but north and south, being long north and south, and less wide along the longitude. Atmospheric pressure belts are idealized seasonal precipitation in Latin America. The pressure belts are the polar high, subpolar low, subtropical high, equatorial low. And then it gets repeated in the South Pole and then repeated in the North Pole. And so hypothetically, the these pressure belts and the wind they create, would go toward the lows. But in reality, real world, the prevailing winds are more complicated than that. These are the prevailing winds in the Americas. We have the westerlies coming from the west, the northeast trades coming from the northeast, southeast trades coming from the southeast, again, westerlies coming from the west. Some of these trade winds are so persistent that even vegetation like trees will grow, will kind of have no choice but to grow with that pressure of the constant winds. And by the way, these winds are also what helps to explain why Columbus and the different ships from Europe, why they arrived to the parts of the Americas that they did, and why trade tended to happen in those directions. Europeans, in order to get to the Americas, first had to get to northern South America or the Caribbean, because that's the way the wind would take them, then up north to the US, and then the winds could take them back to Europe. And so trade tended to follow these trade winds. That's where they get their name from. And also why it was cheaper for in Brazil or places like Haiti. They had a history of treating slaves worse because for them, buying new slaves was often cheaper than treating them well enough, to keep them alive while enslaving them and making them work. And so yeah, all of this helps explain the way history unfolded as well. The orographic effect. You were introduced to this also in chapter 2 of Jockish, where you have the prevailing winds. And this is to point out that even on the same island in the Caribbean, they can have very different climate depending on what side of an island you're in. And so there could be the windward side of an island where the moisture from the wind gets pulled out of it. And so you have one side that might have like a rainforest. And then on the other side, you have very little rain, and you have the rain shadow desert on the other side. And so mountains can create very different climates on different side of the mountains, whether we're talking about an island or we're talking about how the Andes could affect parts of South America as well. Seasons. I don't think there's any questions regarding the seasons, so we might not need that. Yeah. Cyclones. So they're measured according to wind speed. First, we have tropical depressions with less than 38 miles an hour or kilometers, 63. They're storms between 39 and 73 miles per hour. And then hurricanes above 74 miles an hour and above, they become hurricanes, beginning with category 1, 2, 3, 4, and 5. And so obviously the higher the wind speed, the greater the damage of these hurricanes that can begin as depressions or storms before they become hurricanes. I'm not going to test you on the specific miles per hour of each one. Maybe the only one you need to know is 74. Above 74 miles per hour becomes a hurricane. Do know that category 1 is less powerful than category 5, or know the relative order of these, not the specific miles per hour or kilometers per hour. You're not going to be tested on that. Hurricanes can be so, they can go over the same land over and over, year after year. And so this is showing, how Hispaniola, the island shared by the Dominican Republic and Haiti, for example, over the course of over 100 years, how many times hurricanes have gone over this land. This can help show how the hurricanes themselves can be actually even bigger than the islands themselves. You don't have to know the specifics or this whole list of hurricanes. Suffice to say that there can be a lot of variety in how many people die from hurricanes or the cost of the damage. And also that this isn't something that affects just Latin America. Those warm ocean currents and the winds, come from the Caribbean toward the US. So it's something that's shared often by the Caribbean and the United States.